Hey guys, okay, this is lesson 5.3, and what we're going to do is we're going to be using proportions, as we have been doing quite a bit in the last couple of chapters, and we're also going to identify similar triangles inscribed in a larger triangle, and we will certainly discuss exactly what that means as far as inscribed, okay? For our warm-up today, you're going to solve the ratios or the proportions, okay? So what you do is x times x is going to be x squared equals 3 times 27 is 81. Square root and x equals 9. I'm trying to make sure I have plenty of room. Okay, now the next one you'll do is you will cross multiply. X times x is x squared equals, now you're multiplying here. We haven't done that necessarily in a proportion setup, okay? But you're multiplying. Remember the rules of multiplication. What's outside goes together. What's inside goes together. So that's going to be 9 square root 36, okay? Now, remember, square root 36 is going to be 6. So 9 times 6 is, move over, x squared equals 54, okay? So now I'm going to find the square root of that, okay? And x is going to equal, I know that's not a perfect square, so I need to break that down. And I'm going to go with the largest perfect square to break that down, which is square root 9 times square root 6, okay? And I'm going to have 3 come out of there. 6 will stay inside, so 3 square root 6. Okay, last one. I'm going to cross multiply. So I will get x squared equals, let's see, 12 times 15, 180, square root. And I know 180 is not a perfect square, so I'm going to have to go to y equals 180 divided by x and take a look at my factors. And let's see, when I do that, I see 36, square root 36 times square root 5. Square root 36 comes out as 6, and I'm left with square root 5. So x equals 6 square root 5. All right, let's take a look at this inscribed similar triangles. Okay. We know that if shapes are similar, that means they have the same shape, just not the same size, okay? And this is what the inscribed similar triangles theorem states. If an altitude is drawn from the right angle of any right triangle, then the two other triangles formed are similar to the original, and all 3 triangles are similar. Okay, so this is what it's saying. Originally, you had this larger triangle here, and then they made the altitude. Remember, that's the same as the height, okay? And when you do that, just by putting an altitude here, you've gone from one giant triangle to the giant triangle plus this one. Remember, because of a linear pair, this is also going to be a right angle. You have this smaller triangle here, and then you have another triangle here, all of them having a right angle in it, so they're all 3 right triangles, okay? So then basically, if you were to separate them, that is how it would look, okay? And you would write the similarity statement. Now, we haven't done that in a couple of lessons, okay? But you'll do fine. So let's just take a look at this for this very first one, okay? And I highly advise sketching it out, because in a minute you're going to be looking for missing sides, and it's a whole lot easier if you sketch it out, okay? So just don't be lazy, just do that part of it. The first thing I want to do is add this right angle part of it, okay? That just kind of helps you see all three different ones. The first triangle that I'm going to do is like the big one. Now, you don't have to make the size correct. What's important is that the letters are correct. So if this is my large triangle, here's my right angle, okay? So I'm going to start at the top, I-R-E. So I-R-E, okay? Then I'm going to do the next one. And this time I'm going to use this one. So cover up that smaller one. This is what I'm looking at. Here's my right angle. So this one would be E-T. Excuse me, E-T-R. So it would be it would be R. Wait a minute. Yeah, that would be R-T-E. R-T-E. I'm confusing myself. Okay, now the smaller one, and if you want to shade them, you know I don't care about that. Okay, if you want to shade it, you can. All right, so this is what we're looking at. So cover it up, okay? You're looking at this right triangle. You want the smaller leg, okay, first, and then the right angle letter goes in the middle, okay? That's what we've been doing. So that smaller edge is going to be I-T-R. So this is I, this is T, right there where my right angle is, and this is R. So now that I have it written out, and the reason, first of all, the reason I'm doing it is because in a minute when you have to find missing sides, this is going to be critical, okay? But another reason is because, as you know, when you write similarity statements, you have to write the corresponding angles in the right order, okay? So the similarity statement would be triangle, I-R-E, is similar to triangle, R-T-E, is similar to triangle, I-T-R. Now that way, when you draw them out like that, and you make sure that you've drawn them out correctly as far as where their letters are concerned and all that kind of stuff, then that way you can make sure that you get the corresponding angles, which means you will also get the corresponding sides. All right, let's take a look at this. Okay, so for example 2, it says find the value of x. So, and let me just tell you, and I've told you guys this before in geometry, sometimes there's more than one way to set it up. You may not choose exactly the way I choose to set it up, okay, to solve. But as you know, I've told you this from the start. As long as what you do on the left side of your proportion is the same way you set up the right side of your proportion, cross multiply, and you'll get the correct answer, okay? So let's take a look at this triangle. X is here, okay, which it could be the bottom of this triangle, which is the bottom right there by the right angle. There's an X, and then 8 would be like the hypotenuse of this triangle here, okay? So I have the bottom and the hypotenuse. And then if I look at the giant triangle here by the right angle, I have the bottom and I have the hypotenuse. Okay, so that would work because that's what I need, bottom, hypotenuse, bottom, hypotenuse. So I'm going to draw them out. And again, you don't have to make it exactly the size, but I'm going to do the big one first, okay? So that's EDG. And this is 6, and this is 8, and my hypotenuse is 10, okay? Now, if I use this one, okay, GFD, I have 8 as my hypotenuse, and I have X on the bottom. Now that will help me. I'm not even going to use this 6 right here, okay, the way it's set up. Here's my constant right there, 10 over 8. equals 8 over x. Cross multiply. 8 times 8, 64. 10 times x, 10x. Divide by 10, and x equals 6.4. Okay, let's take a look at the next one. Example 3. Find the value of x. Okay, so again, just pause a minute and look. Okay, the x I'm seeing, and this one's, let's see, it looks like, if you need to sketch that in to help you visualize, please do. But this looks like you have a smaller one with 4 on the bottom and x as my hypotenuse. So I have hypotenuse and the bottom. And then let's see if I have another triangle. Yes, I do. If I use the large triangle, I have the bottom and the hypotenuse. So that's going to work. Okay, so I'm going to do the large triangle first, okay, which is R at the top, S at the angle, and T on the smaller leg. And let's see, the measurements of the large triangle are X on the bottom and 20 on the hypotenuse. Okay, now let's do this smaller one, SVT. Another reason it's good to label that is because if they ask you to also write a similarity statement, then you've already got the corresponding angles written out. Okay, so it's just a good idea. All right, now the measures of the smaller one is 4 on the bottom and X on the hypotenuse. So now when you take a look at this, you're thinking, I've got an X and an X. I don't have a constant. That's okay. We've been doing radicals, okay? So you'll just ease right into how to do that. So this will definitely go together. 20 over X equals X over 4. Cross multiply X squared equals 80. Don't panic. Square root. It's all stuff you know how to do. And X is going to equal, break that down, okay? You will break that down into, actually, jump the gun a little bit on that X. I got to have a little more space. When you find the factors, it's 16 times 5. 16 will come out of the sign as 4. Square root 5. So X equals 4 square root 5. If you want to write that on here, 4 square root 5. Okay, now you have that side. Now this next question jumps right in and says, now find the value of y. All right, so when we look at this, I have, let's see, I have the large one, the large triangle, I have the hypotenuse and the side of y that I'm looking for, okay? So let's see, I'm going to sketch it out and then I'm going to write the problem over here. So I have the large triangle, and then I'll match up and see which one I can match up with. I know that I have 20 on the hypotenuse and y on the large side, not the small end, but the large side there. And let's see, so what do I have where I have the back side of 1 and the hypotenuse? Oh, I see it. Okay, what you have to do here is 20 minus 4. That'll be 16. So we won't even be using that smaller triangle. We'll be using the medium-sized one here. Here's your right angle. Your side is 16 and your hypotenuse is y. So the side is 16 and the hypotenuse is y. So now when you set that up, y side goes with side. So we put it over here. Y over 16 equals 20 over y. Cross multiply. 20 times 16 is 320 equals y squared square root. Now 320 is not a perfect square, so I'm going to need to break that down in order to find that. And when I go to y equals, I discover that my largest perfect square is 64 times 5. Square root of 64 is 8, so 8 will come outside the sign, and I'm left with square root 5. So my answer is y equals 8 square root 5. So now you see why we spent a whole week working on radicals, okay, when you guys didn't have it at all last year. Now you know why, how it applies to your right triangles, okay? All right, number 5. Find the value of x. So let's see, when we look at this, we have the smaller one here where we have the small leg, the bottom is 9, the larger leg is x. And let's see, what would I have? If I have this one, I also have the longer side and then the leg. So I won't even be using the largest triangle at all. I'll be using the small and the medium. All right, so the way you would set that up is, I'll do this one first, okay, the medium. It's going to have 27 here, and x would be on the bottom, okay? And then when I look at the smaller one, of course, here's your right angle on this one, okay? And I have 9 on the bottom and x on the side. So when you set that up, corresponding sides would be 27 over x equals x over 9. And then cross multiply. X squared equals 27. 27 times 9 is 243. Now you're going to do the same thing here. Let me scoot this up a little bit. Square root, and then you're going to go to, I know 243 is not a perfect square, so I'm going to go and take a look at how I can break that down into a perfect square times something, okay? And for 243, here it is, 81 times 3. 81 is a perfect square. That would be 9. I'm left with square root 3. So x equals 9 square root 3. Okay, number 6. Almost done. Just have a few more questions we got to do. Okay, so now I'm going to be looking at finding x and y. So again, if you need to sketch that out there, you've got that angle there. So you have the really big triangle, okay? And then you have the medium one here, and then you have the smaller one here. Now, one thing I will notice is that on this biggest triangle here, the hypotenuse would be this whole thing, which would be 20 plus 15. That's going to be 35 if you need the hypotenuse, okay? Let's see how we have to set it up. To find x, here it is. So I need, for this triangle, I have x at the hypotenuse and 20 on the side. So I need a hypotenuse and a side, not a bottom or a base. So then I look at what I have, and I'm going to set that up with, I do have the hypotenuse of the bigger one. I guess I could go with that. Let's see. And x, yeah, there we go, on the bigger one. On the larger one, I have a hypotenuse of 35, and the side is x. Perfect. Okay, so now I can set that up because 20 is my side, and it will go with x, okay? 20 over x equals x over 35. Cross multiply, and x squared equals 700 square root. I know that 700 is not a perfect square, but I know that I can break that down into 100 times 7. Square root of 100 is 10, square root 7, so x is going to equal 10 square root 7. Okay, now I need to set it up to find y. So let's see what I have here. Excuse my drawings. I know I'm not the greatest artist, but what matters to me is that I set it up correctly when I go to solve it. Y is the base and hypotenuse. The base and hypotenuse. Oh yeah, I see it. Okay, so I'm going to have the base is y, and the hypotenuse is 35 of that largest triangle. Okay, and then on this small one, if I can turn it sideways, you can see it. Okay, I have the base of 15, and the hypotenuse is y. So the base is 15, and the hypotenuse is y. So now when I set this one up, I'm going to have 35 over y equals y over 15. Cross multiply. Y squared equals 35 times 15 is 525. Find the square root. And let's see, I don't think that's a perfect square, so I'm going to need to go to, let's see, that one I don't know right off the top of my head, so let me look and go to y equals, there we go. Okay, so when I looked up my factors, I saw that the square root of 25 times the square root of 21 is 525. And, of course, square root of 25 is 5. That comes out of the sign. I know 21 is kind of big, but you could look up the factors. 1 times 21, 3 times 7. That's it. None of those are a perfect square, so there's not a hidden perfect square inside of there. So y is going to equal 5 square root 21. Whew, okay. Now, something easy is this, the geometric mean, okay? So let's just talk about that a minute. The geometric mean of two positive numbers, a and b, is the positive number x, such that a over x equals x over b, or x squared equals ab, and x equals square root of ab. I know that sounds so confusing, okay? But this is what that means. I'm going to write it kind of small. Hope you can see it. But all these letters, this is what it means. If you have a over x equals x over b, okay, and then you cross multiply, you're going to have x squared equals ab, okay? That's that part of it, okay? X squared equals ab. And then we do the square root, okay? And when we do that, x is going to equal the square root of ab. So even though it looks like gibberish, once you look at it, it does make sense, okay? So let me just tell you how you do this. You're going to love this because it's not hard at all. You are going to use your skills of finding radicals, though, definitely, okay? So this is how you would do that. To find the geometric mean of 24 and 36, this is how you do that. You say x equals the square root of 24 times 36. And then what you're going to do is you're going to simplify each one of those using your skills of radicals. You know the square root of 36 is going to be 6. That comes outside the sign. 24 is not a perfect square. However, you can break that down into 4 times 6. The square root of 4 is 2. Take that out of the sign, okay? And then you're left with square root 6. So then your answer is 6 times 2 is 12, square root 6. And that is the mean. Now, let me explain a minute about mean, okay? Mean is when you average something, okay? You're averaging something. So the mean is being able to, I guess you could say, like you're simplifying and finding the average, okay? All right, so let's do the next one. X equals square root 18 times 54. And neither one of these are perfect squares, so you're going to have to break them down, okay? 18 would be 9 times 2. Square root of 9 comes out as 3. You're left with 2. 54 would be the square root of 9 times the square root of 6. Square root of 9 is 3. That comes out, and you're left with 6. Now, just like the rules of multiplication, 3 times 3 is 9. Square root, 2 times 6 is 12. Now, before you put that final answer, look carefully here. This is where some of you have slipped up in the past. You've left too big of a number. Now, I know you're expecting some big, large number, but 12 has a perfect square inside of it with 4 times 3, okay? So you have to take that perfect square out of there, and then you're just left with square root 3. So your final answer would be 9 times 2 is 18, square root 3. So just use that y equals trick I showed you on the calculator to get all of the factors. Even if it's a number as small as 12, you might forget that it's got a perfect square inside of it, and then you'll get the wrong answer because you don't take that out of there, okay? So use the calculator until you get a better grasp on your multiplication facts. Some of you do fine, but some of you still struggle just a little bit with getting all the facts, okay? So until then, just double check yourself, okay, with the calculator. And that concludes our lesson.